off on estimating square roots using squares. And now we're going to just build squares. In other words, the goal is if you're given a line segment, you should be able to estimate the length of it using square roots without a ruler. Okay? But with the ruler, you know, it's nice to at least believe your work makes sense. So I am going to use a ruler just to, and you guys can do the same. Like in units, yours isn't going to match up to be, I can't remember if yours, because your paper's reduced, this is not going to be centimeters, but in units, this looks like 4.5 units, the length of that black line. You guys see that? Okay, so yesterday we built squares. We were given squares up here, right? And once we knew the area of a square, we could find the length of the side. And then we learned how to estimate. Okay, so we're going to go through that today, but we only have a segment, so we have to build a square. So if you look at this square here, from one point corner to another, it's over 2 units and down 4 units. So when you build a square, you use that ratio to make the right angles. So, like I'm going to make a right angle, but instead, I'm going to reverse the direction. So I'm going to go down 2 units over 4 units. And can you see that connecting those 2 points, I have a right angle, and you can follow along and do that on your paper. You should be drawing in this segment. Everybody see that? So I'm building a square. Okay, and now from this point, I have to rotate my straight edge again to make another right angle. Okay, and you can kind of see where it's going to hit, but also you should be using this light green. So we went left 2, down 4. Now we reverse it, down 2, right 4. And then we reverse it again. So we're going to go up 4, right? And over 2. So we would go basically up 4 over 2, and we'd end right here. When you do that, you can see there's a vertical of 4 and a horizontal of 2. And when I bring my straight edge in, it connects what I guessed it was going to connect. You develop an eye for this, right? And you just start to see the pattern. So you connect and you continue to do that, and then you already just connect your first point right to your last point, and you get your square. You're going to do that on your sheet. Then you take your straight edge away, and you're back to where you were yesterday. And if you notice, my highlighted green, not only did it help me draw my square, I was going to need to do it anyway, because if I want to find the area of the red square, I need to surround it with a regular, a square that's oriented to capture the whole shape.
Then you
Find the area of the green square, right? And it's a, what is it, Soham? It's a 1, 2, 3, 4, 5, 6 by 6. Right, 6 by 6. So the area of the green is 36, right? So how are you going to figure out the area of the red? You're going to do that?
Yeah. When you, the triangles, the little triangles.
Yeah, these triangles outside.
They're 2 each.
They are 2 by 4s, right? Which is 8 units divided by 2.
Oh, 4.
They're 4 each, right? In this case, they're all 4 unit triangles.
Then you minus 12 from 36.
So you minus
Oh, you guys.
16, right?
Yeah, that's what I meant. And then you get 20.
20. So the area of this, so So the side length,
And you see what goes into the square.
what's the side length?
Square.
Square root of 20, right? And I know you may be somewhere along the way, like if your parents help you, they showed you a way to simplify square roots. We're not gonna do that today. We're gonna estimate our square roots. So this would be a good time to show your parents if they're wondering, and you get help from them sometimes, what we're doing. Because there's so many different levels of math that use square roots. But what we're gonna do is get an estimate of the square root of 20. So let's see, Emerson, what perfect squares does that fall between?
Would be the 25, which is 5 squared, and 16, which is 4 squared.
Right. Okay, so therefore the square root of 20 is somewhere between 4 and 5.
25.
Well, that's what we're going to do. The only time you're going to use, well, okay, so we're going to do a fraction estimate first. So remember, we always use the top square root. How far apart are 16 and 20, Evan? 4. And then Evan, what's the denominator going to be?
5. No.
9.
Yes, it's 9. Okay, and then I don't know if I showed you guys, I showed the last class, what's 4 plus 5? So that 9 comes from different places. It's the difference between 16 and 25. The difference between 16 and 20 is 4, so it's your numerator is 4, your denominator is 9. But if you look at the estimating that we did, let me go to another estimating. Like here, when we started doing lots of estimating, let's go to the pages from yesterday. For example, we estimated the square root of 98. And so we knew it was 9 something. The difference between 81 and 98 is 17. The difference between 81 and 100 is 19, right? So it's 17, 19. So that's our fraction right there. But what's 9 plus 10?
19.
So the perfect squares, when you get the square roots, add those together, that's another way to get the denominator.
That is so cool.
Yeah, and so
Fascinating.
then when we go back to the problem we're actually working on, right here, we know it's 4 4/9. That's a repeating decimal. Does anybody know that repeating decimal?
4. I mean, 4.
Yeah, it's 0.4 repeating, and if you don't believe me, let's look, because I do have a cold, and sometimes I say crazy things. So, 0.4 repeating, right? So this, all by hand, is 4.4 to 1 decimal place. Remember, these are, we would say, all approximate, right? Because it's not exact. We're using a method of estimation. So,
4 and 4 minus equals.
yeah, and then we went back to our square. Each one of these is 4.4, about. So if we multiply 4.4 times 4.4, we should get close to our area of 20. But it's not going to be exact, right? Because it was an estimate. So let's say 444 times 4.444. Not bad, right? So it's a good estimate. Okay, so you guys, why don't you try because this is kind of crowded, go back to this page and try the line on the far right. And that's all we're going to work on today. We need some class time to work. So, in other words, find the length using that method of this line.
And I'll run the outside area.
So you have to go through the process.
Yeah, I know I already did that.
Oh, you already did it?
Yeah.
Yeah, so you would need the area of each square. Okay, so how many people are already there? Okay, so if you're not, get caught up and I'll build it over here. Oops. So it's 1 to 4, right? Instead of 2 to 4, so over 1 and down 4. And then I need to move the ruler. And now I would go down one over 4, right? That would be my new line. So, right in there. I'm gonna build my square in while you guys do that. So, Quinn, is this what yours looks like?
Yes.
And then
And then we got the area of the
17, the outside or the inside? Okay, so our outside area was, I kind of missed the dots there. There we go. Here's our outside rectangle. It was 25, right?
Yep.
And each one of these triangles was 2?
Because it's
Can I see that? So 25 minus 4,
Yeah, 8. And you have 4 of them.
oh yeah. Oh, sorry. 2, 4, 6, 8. I actually can't count. Must have been the addition that got me. So 17. So this is 17. So the side length is the square root of 17, which is 4 something, right? So we want square root of 17, and you put it between what, Quinn?
16 and
25. So this is 4, and that's 5. Okay. Use my left hand today because so 4 something, right?
4 and something nice.
Something ninths, right, Joe? Because if you just look at these two,
It's 1 9.
that's the difference, right? Let me fix that 9. That's pretty bad. All right, 4 and how many ninths? 1, because the distance here is 1, right? The distance there is 9. Hey, I'm working hard here. 4 and a 9. So that's 4.1 repeating about. So remember, these are no longer equals, they're just about. They're approximations. So 4.1 repeating.
Is it okay if you leave it in the 4 and 9 form, or do you have to?
So if it were a test without a calculator, you would leave it in the 4 and the 1 9
Okay.
form. I'm doing both, just so you, what's nice about the 4.1 is if you wanted to take, after you did the whole thing, why don't you pick that up? Without a calculator, you can kind of check your accuracy. So square root of 17 from the calculator is 4.12. 1 divided by 9 is 0.1 repeating. So the calculator is just kind of a nice way to check your final work. So this is about, the length of that line was about 4.1 units.
Mr. Crowder.
Thanks, Mr. Crowder.
Welcome.
Okay. Good on that?
Yeah.
All right, that's it. So here's your problems. I want you to look, I'm going to stop this. I'll